Okay, so now that we've established all our line forms, let's go ahead and do some graphing. So in the first one, I was very kind to you because I already gave you, right, the slope-intercept form. It's already in that nice, cool, sexy form, right? So all I got to do is read information. What do I have? Well, the fraction there in front of the x tells us what our slope is. So we're -1/2. And then there's our b, so that's telling me my y-intercept. When x is equal to 0, right? You can almost, when x is equal to 0, that's gone. Y is b, or excuse me, y is 3. So we have a point to plot now, right? My y-intercept, and I've got a direction to move. So let's go do it. So I'll go over to my grid, and I'll plot the point 0, 3. There that is. And then the slope is a negative, so that means we're going to be going down. So you can either put that negative upstairs like we commonly do, or you can put that negative downstairs, right? And watch what happens. If it's upstairs, that's telling me to go from this point, go down 1 and to the right 2. Down 1 and to the right 2. Down 1 and to the right 2. So that is one way to interpret -1/2. But if I did it this way, this is actually telling me to go up 1, and then where that negative is, we're going to go up 1 and actually back 2. Up 1 and back 2. Up 1 and back 2. So you'll notice, no matter which way I use it, just don't apply it to both, right? Because if you apply it to both, a -1 over a -2 is a +1/2, and then I would be going this way. So be careful. There's a negative. You decide where you want it. Upstairs, move down to the right, or downstairs, move up into the left. Okay, so there's a little, hopefully, review of slope. But more importantly, we have our a graph, right? It looks like one solution point is 2, 2. Looks like another one is 4, 1. Looks like 6, 0. Right? -2 and 4. Right? We got a bunch of them. We know there's an infinite, but just again, very, very fast way to generate the solution points to graph by using this really nice, cool slope-intercept form. All right, so let's transition then. Got another page, right? So what about the next one? All right, so on this next one, right, what form of the line are we looking at? Right, this is in point slope form. So I'm going to ask you guys, fight the urge, right, to rewrite it in slope-intercept just because you like it, because it's actually a train wreck. So if you be my guest to try it. But as point slope, how about I write the formula right below it, and let's mix and match who's who. So again, clearly, what's the slope? Well, that's that fraction sitting right in front, right, of that parentheses there. So we know what to move. What about x1 and y1? Well, remember, x1 is the number being subtracted from x. So what number is being subtracted from x? 5. y1 is the number that's being subtracted from y. So what are we subtracting from y? We're subtracting the number 2, right? Y take away 2. 2. X take away 5. All right, we're taking away 5. So now I'm good to go. I've got a location, 1, 2, 3, 4, 1, 2, 3, 4, 5, and 2. So I've got 5, 2 on my graph. And then the slope is telling me to do what? It's telling me to go up 4, 1, 2, 3, 4, and then over 7, 1, 2, 3, 4, 5, 6, 7. So we're kind of off the board. Or I can go down, right? This would be the double negative. I can go down 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. Right? I guess we have -2, -2 on the graph. Again, you could easily check that by plugging it in. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, and 7. So there would be the graph of this equation, keeping it, right? I think we're 1, 2, 3, 4, 5, 6, 7, 8, -8, and -6, I believe, is that data point there. So there's the graph of that. No, you don't need to put it in slope-intercept form, all right? Or excuse me, slope-intercept. You have everything you need in the form that it's in, so just use it. So the next one, C, again, if you look at it initially, right, what form of the line are we looking at one more time? Right, we're looking at point slope. So since we've recognized it as point slope, let's use point slope. But we do have a bit of a challenge, right? Let me write the formula, right? Again, m is probably the clearest thing. It's the fraction right in front. What's a little tougher is what's x1 and y1. And the formula is expecting a subtraction statement. And unfortunately, we have an addition statement. But I don't know if you guys remember your little, there was a little quiz we did for fun on Canvas. How can I rewrite x plus 1? I can rewrite it as x minus a negative 1. So there's your x and x1. So what's being subtracted away from x? Negative 1. Same thing over here, right? Y plus 2. Well, that can be rewritten as y minus a negative 2. And so what are we subtracting away from y? Because that's what I need for the formula. What's being subtracted from y? Negative 2. Now I have a point. I have my movement. I'm off to the races. So negative 1, negative 2, right? That's the point I'm starting off with. And then again, there's a negative, so you decide where you want to put that negative. If you put it upstairs, we're going to actually drop down 1, 2, 3, 4, and move right 3. If you put it downstairs, we're going to go up 1, 2, 3, 4, and to the left 3. And there, right, are my 3. Usually ask for 3 points, you guys. There's my 3 points. It looks like one of them is 2, let's see, 2, 3, 4, 5, 6, negative 6. And it looks like the other one is at negative 4, comma 2. Right? And so there is the graph of that equation using our point slope form. So again, pretty useful form if you know what you're looking for. If you try putting that in slope intercept form, which is doable, you get all these nasty looking fractions. So be my guest, and then you got to plot fractions, and that's nasty. Why don't you just use what's right there in front of you? Right? So I know it's the ugly duckling, but it's giving you what you want. Couple more graphs, all right? So let's graph a couple more times. So D and E, all right? Now the first thing you're going to look for is neither one of these fit any of the forms that we've been talking about, right? None of them whatsoever, all right? So there's the first thing that we're like, whoa, okay, you know, where's the y equals mx plus b, and where's y minus y1? It doesn't fit any of our things. So I'm going to go back to point plotting, right? Again, remember, when in doubt, you can always point plot. We just simply have to find, right, ordered pairs that make this equation true. And when I look at this equation, there's only one thing that really needs to happen. That one thing is y equals negative 2. So throw out your favorite number, right? One of my favorite numbers is 2. So if I was to let x equal to 2, what would y have to be? Well, according to this equation, it would have to be negative 2. Maybe you don't like 2. Maybe you like 3. Right? So if x is equal to 3, what's this y value saying? Well, it still has to be negative 2. If x is 0, we have to be negative 2. If x is negative 1, I would still have to be negative 2. Right? What makes this equation true is the y coordinate has to be negative 2. So now that I've got several solution points, let's go plot them and see what we got. So we have 0, negative 2. We've got 2, negative 2. We've got 3, negative 2. I even have negative 1, negative 2. Do you see the pattern? Right? Yeah, our pattern is basically this nice horizontal line. Okay? So a couple of things I need to say about horizontal line. The way you create a horizontal line is you basically just let y equal a number. So if I had to let y equal to 3, that would have been that horizontal line right there. Right? If I would have let y equal to 3 halves, right, that would be that line right there. Okay, so to get a horizontal line, you basically just let y equal a number, right, just like we did there. The other thing I will say is that the slope of a horizontal line is 0, because the fact is, when you think of this, this is the change in y over the change in x. So I can change x, right? This is changing all I want. So this is any number. But the change in y, I'm not going up or down. So when you take 0 and divide it by any number, what you get is 0. So a couple of things there. So again, to get a horizontal line, you let y equal a number, any number, and then the slope of that line, the rate of change, will be 0. So if you're a thinking man, right, or lady, what do you think the graph of x equals 3 is going to look like? All right, take a stab. So if y equals a number is a horizontal line, x equals a number should be a vertical one. So let's test that theory. Again, let's do some point plotting. In this case, right, in order to be a solution to that equation, x has to be 3. So if I tried letting x equal something else, I'm already wrong, right? 2 is not equal to 3. So x has to be 3, and y can be anything that I want it to be, right? Because there's no restrictions on y. Y can be anything, x is stuck. It has to be 3. Graphing these points, we have 3, 0, we have 3, 1, and we have 3, 2. And there is your vertical line. So the moral of the story here is if you want to create a vertical line, right, you're going to let x equal any number. So if I had x equal to -2, that would generate that vertical line, right? If I had x equals to 5 halves, right, that would probably generate that vertical line right in there somewhere at 2.5. Slope in these cases is what we call undefined, because what's happening here is that the change, right, the change in x, the run, if you would, is 0. There is no change, but you know, y can be whatever it wants. Go up by 1, go up by 2, go up by 3, but there's no change. And of course, what do we know about division by 0? It's undefined. So vertical lines, you let x equal any number you want to create that vertical line. As far as the rate of change is concerned, it is undefined. So there's your graphing. All right, let's go on to another topic.